In this lesson, we're going to talk about some more advanced techniques with partial fractions. The first one we're going to look at is when we have a linear factor that that repeats. In all the problems we've looked at previously, each factor was unique. In this first one, when we factor x squared minus 4x plus 4, the factorization of that is x minus 2 times x minus 2. Now, because of that, we can't simply split it into two fractions with denominators of x minus 2, because then we'll end up with the exact same results. So what we do, since this repeats twice, one of our denominators is going to be that factor raised to the second power, and the other denominator is going to be that factor raised to the first power. We're going to take, let me see it right here, we're going to use every power of the repeating linear factor, starting at the first and going up to the number of times that it repeats. So this one repeated twice, so we've got that factor raised to the first, and we've got it raised to the second. Alright, then multiplying these out, we have a times x minus 2 plus, we have a times nothing. A is already over the common denominator. Plus b times x minus 2 has to be equal to 4x minus 3. And because of this, our system of equations is going to be very simple. We've got b equals 4, and we've got a minus 2b equals negative 3, and so a is going to be equal to 5, just substituting the 4 into that second equation. And so we're now integrating 5 over the quantity x minus 2 quantity squared, and 4 over the quantity x minus 2. And now we can just go ahead and integrate those. I'll bring the 5 out in front. The antiderivative of 1 over x minus 2 to the second is negative 1 over x minus 2 to the first. Don't fall into that trap that it's always going to be a natural log. That's only when the denominator is raised to the first power. Plus 4 times the natural log of the absolute value of x minus 2, plus c, and I think I'm just going to clean that up a little bit and put the 5 in with that first fraction. And there's our integral. Alright, let's look at example 2. Here we again have a repeating linear factor, but we have it this time with another factor. Not terribly difficult. The other factor is written as one of the denominators. And then we're going to actually have three fractions here, one of which has x plus 2 to the first power, and one of which has x plus 2 to the second power, since it repeats twice. Alright, now in order to determine our system, we need to multiply each of these numerators by the factors that are missing from their denominator to get to the common denominator. So we're going to take a times the quantity x plus 2 squared. I'm just going to expand that out. And we're going to take b times x plus 2 times x minus 3. And the c, we only have to multiply by the x minus 3. Okay. And that has to be equal to 5x squared plus 6x plus 12. And so our system is going to be a plus b equals 5. 4a minus b plus c is equal to 6. And 4a minus 6b minus 3c is equal to 12. Okay. Now, since I have an equation already that just has a and b in it, I'm going to eliminate c with the other two equations. I'm going to multiply the first equation by 3 and add the two together. Gives me 16a minus 9b equals 30. And then I'm going to take this first equation here, multiply it by 9, and add it to my new equation. That gives me 25a. The b's cancel out. Is equal to 75. So a equals 3, b equals 2, and let's see, 12 minus 2 is 10, and c equals negative 4. So our integral now is the integral of 3 over x minus 3 plus 2 over 2 over x minus 2 minus 4 over x plus 2 upon b squared. And now I'm going to integrate one by one. That gives me 3 natural log of the absolute value of x minus 3 plus 2 natural log of the absolute value of x minus 2 minus 4 times negative 1 over x plus 2 c. And I clean that up a little bit. And arrive at my final answer for my integral. Alright, we'll stop there. Join me next time for one more example of an advanced partial fraction problem.